Okay, today we are working on lesson 2 of organic chemistry, how to name branched alkanes. So hydrocarbons are not always straight chains. Carbon is stable when it forms 4 covalent bonds. This means it could bond anywhere between 1 to 4 carbon atoms, resulting in a branched chain. An atom or group of atoms that can take the place of hydrogen atom on a parent hydrocarbon are called substituents. The longest continuous chain is the parent chain and does not necessarily need to be written in a straight line. So circle the substituents in the following hydrocarbons. So we're looking for the branches off of the main parent chain. The first thing you really need to do is identify the longest carbon chain. It's not always going to be a straight line. So find the longest carbon chain. In our first example, our longest carbon chain is right along those 4 carbons here. So the substituent is the branch off of the parent chain, the longest carbon chain. So here is our substituent for the first example. The second example, it's another example where the parent chain is in a straight line, but it won't always be in a straight line. So our longest carbon chain here is 1, 2, 3, 4, 5, 6 carbons. And so to circle our substituents, those are the branches off of the parent chain. So there's one there, and one there. And in the last example, you might be looking at it thinking, oh, here's our parent chain. Nope, that's wrong. The parent chain is actually curved. So you have to look for the longest number of carbons. On this end here, you can see there's 2 carbons, but coming off of that is 3 carbons this way. So you actually draw or identify your longest carbon chain as this, and then just double check once you get to here, is this part over here or is this part over here where the chain's going to continue. It actually doesn't matter for this example because both directions have 2 carbons, so I'm just going to keep going straight. So this is our longest carbon chain, our parent chain, with 1, 2, 3, 4, 5, 6, 7, 8 carbons. And to circle the substituents, it's the branches coming off of that curved parent chain. So over here is a branch, there's a branch, there's a branch, and here's a branch. So it's not always going to be in a straight line. There are going to be trick questions where it's curved like that. Okay, hydrocarbon substituent derived from an alkane is called an alkyl group. An alkyl group is essentially just an alkane with one of the hydrogens removed. An alkyl groups are named with the same prefix as alkanes, so meth, eth, pro, bute, but you change the suffix to -il. So this example here, we have 2 carbons. 2 carbons is eth. It's a branch, so we call it an ethyl group. Ethyl group. An alkane with 1 or more alkyl groups is called a branched chain alkane. Okay, so I want to sort of identify this ethyl group here. So normally ethane is 2 carbons with hydrogen, 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 hydrogen. Okay, that's what ethane looks like. But when we change it to an ethyl group, instead of having a hydrogen over on one of these ends, that hydrogen disappears, and this allows it to create a bond with some carbon in the parent chain. Okay, steps for naming branched alkanes. They're pretty easy to name, you just follow these steps. So this is the example we're going to be working with, this big molecule here. Step 1 is to identify the longest carbon chain, and that's what we call the parent chain. So the longest carbon chain in this example, see if you can find it, and tell me how many carbons are in the longest carbon chain. So here is the longest carbon chain along the top. It is in a straight line for this example. And it has 1, 2, 3, 4, 5, 6, 7 carbons. Step 2, number the carbons from one end of the parent chain to the other in such a way that the substituent groups get the lowest possible number. So you can number starting at this end over here or starting at this end over here. You want to number at whichever end is going to give your branches here, 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 the lowest possible number. So if we were to start at this end, we'd have 1, 2, 3, 4, 5, 6, 7. The branches are occurring on carbon 4, carbon 5, and carbon 6. If we were to number in the opposite direction, 1, 2, 3, 4, 5, 6, 7, now they're on carbon 2, carbon 3, and carbon 4. 2, 3, and 4 is obviously lower than the 4, 5, and 6, so we don't want to use the top one, we want to use the bottom one. Okay, step 3. Add the numbers to the names of the substituent groups to identify their location about the parent chain. Use dashes to separate numbers and words. Okay, so we've got carbon 1, 2, 3, 4, 5, 6, 7. So we want to name these substituents, including their numbers. So this first one here, the number is 2. We use a dash to separate the word, and we find the name of this branch here. So how many carbons are in the branch, and then find the prefix for that. So what is the prefix we use to name this branch here? Well, it has 1 carbon, and the prefix for 1 is meth. Then the suffix we use for a branch is -il, so methyl. Then this branch here is on carbon 3. It's another 1 carbon branch, so the name is going to be the same, methyl. And take a second to figure out the name of this branch here. So the number, dash, then the name. So it has 2 carbons. The number carbon it's coming off of is 4. So 4, 2 carbon prefix is eth, and the suffix we use for a branch is -il. So this one is that one, and this one is that one. Step 4, use prefixes to indicate the appearance of the same group more than once. So we had on the last slide 2-methyl and 3-methyl here. You don't want to go 2-methyl, 3-methyl. We sort of group them together because they're both methyls, they both have 1 carbons. So instead of calling it 2-methyl, 3-methyl, we call it 2, 3 dash, and then we use the prefix di because there's 2 of them. We would use tri if there's 3 and tetra for 4, but there's 2, so we say di-methyl. And that indicates that there's a methyl group coming off of carbon 2 and coming off of carbon 3. Okay, then you have to list the names of the alkyl substituents in alphabetical order, ignoring the prefixes. So we had the dimethyl, and that was 2, 3, and then we had 4-ethyl. So this is something that's often kind of confusing because you think, well, methyl is 1, ethyl is 2, so methyl should be first. But they actually have to be named in alphabetical order, not numerical order, and you don't include the little prefix di, tri, tetra. So we're looking at the eth one starting with E and the methyl one starting with M. And since E comes before M alphabetically, that's the one that's listed first. So you name them in alphabetical order with the ethyl one coming first because it starts with an E. So 4-ethyl dash 2, 3 dimethyl. Okay, and then you just take that same name from the previous step and add the name of the parent chain onto it. And make sure you combine everything. It should all be one word. You use hyphens to separate numbers and words and commas to separate the different numbers. So on the last slide, we had 4-ethyl 2,3-dimethyl, and then we add on the name of the parent chain. So remember, this is the parent chain. 1, 2, 3, 4, 5, 6, 7. The prefix for 7, think about it, it's hept. And then the suffix we use for the parent chain is dependent on the types of bonds. So far we've only learned about single bonds, and the suffix for single bonds is -ane. Okay, so that's the name. We'll try one more example. All right, so the first step here is to identify the parent chain. How many carbons are in the parent chain? So this one is a little bit tricky. We have 4 carbons here, and it might look like we have 2 branches here and here, but actually this is a curved parent chain like this. So the parent chain is actually this L-shaped chain here. So there's 1, 2, 3, 4, 5, 6 carbons in the parent chain. And then we want to identify the substituents. So we only have 1 because this whole thing here is the parent chain. So just the 1 substituent. Then we have to number our carbons. So see if you can figure out what number that substituent is going to be assigned. So starting at one end or the other, what number would we assign that substituent? So if we were to start at the top, we'd have 1, 2, 3, 4, 5, 6. And if we were to start at this end, we'd have 1, 2, 3, 4, 5, 6. Obviously, the second method is better because we end up with a 3 on that substituent there. So that's the order we number them in. So we would call that 3 dash and then the name of this substituent. So think about what is the name of that substituent, how many carbons are there? So it's a 1 carbon branch. The prefix for 1 is meth, and the suffix for a branch is -il, so it's methyl. Since that's the only substituent, we just add on the name of the parent chain. It's a 6 carbon chain. So the name of a 6 carbon parent chain, all with single bonds. 6 is hex, and the suffix is -ane. That's it.